Okay, now that we've learned about exponents and working with exponents and expressions, we're able to take expressions that involve exponents and put different expressions together to build what we call a polynomial. This is an example of a polynomial. This is 5x to the 7th power plus 3x to the 10th power minus 7x plus 1. And by definition, a polynomial is a collection of exponents, variables, and numbers that are being added or subtracted. Nothing can be considered a polynomial if there are negative exponents that are on variables. You cannot have variables in the denominator, which result from those negative exponents, and you cannot have square roots on the variable. This is what makes an expression not be considered a polynomial. Inside a polynomial, there's always going to be adding signs and subtracting signs, and those addition and subtraction signs separate what we call terms. So if I was looking at this particular polynomial, this represents a term, this represents a term, this represents a term, and 1 represents a term. So this particular polynomial has 4 terms that are present in that polynomial. Among those terms, you have something called the leading term. Now, the leading term would be the term that came in the front if I had the polynomial written in standard form. Standard form means that I need to begin with my highest power and work my way down. So if I wanted to rearrange this particular polynomial, I could put the x to the 10th term at the front. It's a positive 3x to the 10th, so when I rearrange it remains positive. I want to look for my highest power term next, which would be x to the 7th, so I'll go ahead and write 5x to the 7th, not the 2nd, whoops. I want to put my next highest power term, which would be x to the 1st, so I'll write minus 7x. And then the last term is known as my constant term. That's the term that appears not to have a variable. But let's talk about the variable exponents here. This term has a variable exponent of x to the 10th. This is x to the 7th. This is x to the 1st. And this guy, we want to look at him and say, no, he doesn't have a variable. But he does. He has x to the 0 attached to him. And we just talked about the fact that anything to the 0 power is 1. So x to the 0, although it's there, we don't write it because we know that value is equal to 1. And it's not necessary to put a factor of 1 attached to a term that's already there. So if I wanted to realize what my leading term was here, my leading term would be that highest power term, which would be 3x to the 10th. The degree of my polynomial is the highest power. So this polynomial has a degree of 10. And coefficient. Each term has its own coefficient. We need to be careful about how we write this here. We look at this particular polynomial and we think x is our only variable. So if I were to have a question on my milestone or any test that said, what is the coefficient of the x term? We're a little confused because we think of all of these terms as being x, but they're not. This term is x to the 10th. So each term has its own coefficient. So we would have to list this individually. The coefficient of x to the 10th power is 3. The coefficient of x to the 7th power is 5. The coefficient of x is -7. And notice how I did say -7. We interpret that as a minus, but plus -7 is the same thing as minus. And the coefficient of x to the 0. is 1. We might also word this as saying the constant term is 1. It would mean the same thing as the coefficient of x to the 0. The constant term is 1. We refer to the constant term as the x to the 0 coefficient, or the term that has x to the 0 attached to it. And that's it. Those are your definitions for polynomials. So when your teacher uses these words, we expect that you know them. They're very simple, but you have to be introduced to them and you have to learn them.